Hello guys, good evening. My name is Mohammed Sabir and today I am here with you. In today's sessions, what we will discuss, basically we are taking a topic that is like flywheel design. Basically, the topic uh, comes under the designing and what basically we will learn, you know, basically a flywheel design. First, I'm focusing to explain the what is flywheel. Basically, a flywheel is a device which is used to store a kinetic, which is used to store a mechanical energy and to minimize the fluctuations. Okay, uh, the flywheel is a device which is used to store the mechanical energy, rotational energy. And first, before uh, moving ahead, basically, I think you know about the engine. What is the engine? Basically, in an engine, like four-stroke engine, basically we have a four cycle: suctions, compressions, and working and exhaust. Because the flywheel is used in a engine, okay, mechanical engine. What basically we will learn in these sections, we we want to find out the basic dimensions of a flywheel. Okay, like what should be the radii of a flywheel, what should be the uh, other parameters, like we want to look into that. That's why we are focusing on that. Let's I think you can see in your in this screen, basically in this screen, the four stroke engine, the turning movement diagram of the four stroke engine. What basically we understand by the turning movement diagram of a four stroke engine. Basically, basically turning movement diagram, it gives the a relation between torque and theta. Okay, like in where basically the turning moment becomes maximum, where it becomes minimum, and like how trend, like how it changes with theta, it gives that sense. Basically in the turning moment diagram we have a two torque. Basically the one torque uh, that is generated, and another torque is a resting torque. Generated is what, this is a basically a crankshaft, a flywheel is attached here, the flywheel is attached here, and the when like the engine converts the thermal energy into the mechanical energy, that basically that because of that what will happen, the torque is generated. What will happen? Basically the torque is generated. The torque is generated on a crankshaft due to a thermal energy. Okay, that is basically it is a generated torque and developed torque due to thermal energy. And in case of resting torque, what is the resting torque? Resting torque is basically when we apply a load on a crankshaft, the resting torque also be there due to the generator. Where we use a engine to generate electricity, uh, like in somewhere, like we want to generate electricity in where we use a four stroke engine. Like four stroke engine we have a lot of applications. Okay, this case so basically we have a two torque. The one is the basic torque. We have a two torque. Basically we have a two torque. One torque is our main torque, and this is the resting torque. Like we here we not here we represent, it is represented by, a T mean. Or this is a basically this is basically a the torque which is generated by a thermal energy, which is generated by an engine on a crankshaft. That is basically it changes sinusoidally with theta. Okay, like up you know up now the we will focus on, okay, like how to deal how to deal mathematically, how to model this problem, like what basic physics behind it, because everyone know the how flywheel works, what is the basic application of flywheel, but what physics behind it, okay, like how, like when we go for the design, what fundamental things we should keep in your mind, like okay, you know, in an engine what we are looking, in engine what we are looking, basically we want to be a speed constant, we want to a speed constant throughout the process, but the practical is it not possible, like we always try to minimize the fluctuations, we always minimize the energy fluctuations, you know. When we actually the generated torques basically works against the resting torque, okay, but simultaneously simultaneously the torque is not generated, the torque which is generated is not equal to the t mean, okay, like some gap is always be there, okay, so we always try to find out that ki, like when a cycle over, what fundamentally what a maximum fluctuation energy remains, uh like like will be there, okay, कितनी एनर्जी बच जाती है remaining, like in that sense we are looking at, like in that sense we are finding that ki, like this delta k is present here, okay, and this delta k is present here, and like this basically this delta k is there, okay, this is basically a t developed, is a t developed, and is what is t mean, is t mean, and when we plot a simultaneously in a t theta diagram, this basically the shaded area, it gives the net work done, like net work which is delivered by the engine, okay. Now the time to focus on the, okay, like what is delta ke, delta E is what, delta is what basically the maximum energy minus minimum energy, that is a delta E, okay, nothing else, it simply a maximum kinetic energy minus minimum kinetic energy is what is delta E. Here here we have to focus on that, what are basically a physical significance of delta E. Delta is not a kinetic energy change, basically it is a work done which is provided by a engine, that may be kinetic, that may be electrical, whatever, but we try to convert into a rotational form, that we are using a flywheel. This is a basic concept of a flywheel, this is a basic concept of a, and now let's start again, and what we discussed, basically here we use a delta E. Basically what is the meaning of delta E? Delta is what work done, okay. The work done is equal to a change in kinetic energy, okay, like here we this work done is used as a form of kinetic energy, as a form of kinetic energy, here maximum kinetic energy minus minimum kinetic energy. Here we use this basically by helping this expression you can find out the delta k, it's not tough, basically it's a very easy task, you can easily find out, you can look into that, and we will move the next part of this flywheel design, that is very interesting, and we want to spend some more time in this topic. What is E? E is what? Half I omega square. I is what basically I is a moment of inertia, omega is the angular speed. I is the moment of inertia, and like this I is what, mk square, k is the radius of gyrations, here like we half I omega 1 square minus omega 2 square, here omega 1 is the maximum velocity, Omega 2 is the minimum angular velocity. And easily we can find out half I am omega 1 plus omega 2 omega 1 minus omega 2. Okay, we also write this form of like such that half I omega 1 minus omega 2. Okay, I omega 1 minus omega 2. Okay, this is what half I omega square omega 1 minus omega 2 upon omega. And here we define as a CS the fluctuations constant, energy fluctuation constant. And here like this is a basically a constant that is like is a predefined constant, like by using data book you can easily find out. This is what like basically by analysis of turning point diagram we can find out delta E. Okay, and here like here we use I is what mk square, and omega square omega is what the mean angular speed of the crankshaft. C is the constant, and like these two are the designing parameter. Either we like we have a space constraint, then a k is fixed, and in that time we will work on the m. And if like space constraint is not there, like here like we as a like designer m is fixed, then we look into the k. This is the radius of gyration. This is the space constant factor. Okay, this is a basically a flywheel design. Like this is so simple, the mathematics and these all are the simple thing, but in these thing is this thing basically we will focus on the conceptual part. Okay, like I will also I want to give also one flavor of a flywheel design. Like you can relate with that. Like you know basically what is a flywheel. Like we have a system. This is a basically a body. This is basically a simple body, and when you apply a force into that, what basically happens, it moves along its directions. And due to force basically it velocity of this body changes. Okay, like we want to we want to we want to like maintain a speed constant. What basically we have to do, like we apply a resting force that basically the resting force that is required to balance the speed. Speed, like you can relate conceptually. Okay, like if the applied torque, applied force and resting torques uh, becomes becomes not equal, in what will happen, basically the some fluctuation is always be there. If this applied force and resting force becomes equal, in that time we can say the speed becomes constant, because throughout the process when we do a because when we do a some work done against the some resting force, so the work done simultaneously work done cancel out to each other. Okay, I like throughout the process speed becomes constant. These simple physics is used in a flywheel. Okay, thank you, all the best, keep learning.